Hey everyone, take a listen to this message from our sponsor SmartBear. Whether you want to load test your APIs or browser-based applications, you need to be able to easily scale up volume and identify problem areas. With Load UI and Load UI Web, SmartBear has you covered. Load UI is rockstar of API load testing. Using an intuitive, versatile design, Load UI gives you the power to scale up and out, letting you dial up high volume and real-world load from any number of local and remote computers. With Load UI, it's easy to create and configure tests incorporating all of your OS, application, database, statistics agentlessly. It's fully interactive too, so you can easily modify your tests and fix errors on the fly. Load UI Web is an astonishingly easy-to-use load testing tool for HTML, AJAX, and rich internet applications. Using a browser to naturally record your interactions with your website or app, you can scale up the number of virtual users, monitor server resources during test execution, and even distribute your tests geographically. Reports and charts make it a breeze to explore aspects of how your site or app performs under pressure, and ultimately pinpoint performance issues proactively. Load UI and Load UI Web by SmartBear ensure outstanding performance across your entire web stack.
It's time for PerfBytes.
What the is PerfBytes?
The fourth square meal of the day. Don't put much PerfBytes. Waffles, microwave ready. Blah 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 blah.
Add nutritional value to your brain.
It's time for PerfBytes with your hosts Mark Tomlinson and James Pulley.
PerfBytes.
Whatever.
Hey, it's time for PerfBytes. Once again, my PerfBytion listeners. PerfBytion, I like that. It's James and I, your life-size, full-form-factored hosts, Mark and James, welcoming you to a special Gadget edition of PerfBytes. Go, go. Go, go, Gadget. Go, go, Gadget.
Now, Mark, what geek doesn't love their gadgets?
Everybody loves gadgets. That's why they're taking off like crazy. And here we're going into the holiday season in 2014, and the predictions are it's going to be like gadget explosion. Everyone's going to be running every kind of gadget that there is. Of course, Apple just announced the Apple Watch.
And Motorola, almost at the same time, about a week earlier, announced the Moto 360 watch, which was part of the Google Wear.
The Google Wear. You can Google Glasses. You can have a Google Watch as well. So you have your Motorola, Google rings, nose rings, maybe a belly button ring. You could have a gadget. You could get your email on your belly button.
I don't want to go there about the vibrating belly button ring. That
could be
bad.
That could be a very exciting thing. You could be bored. Work is boring. You should have a belly button ring that vibrates when you get an email. That's exciting. But you've also got things. James, you and I have done this work in the past with Nike, with our friends out at Nike, and so we got the Fuel Band. Right, that's been around a long time. They're kind of the forerunner actually in a lot of these, cardio. Health data, real-time stuff. So the Nike Fuel Band, there's also the Fitbit is another one.
True,
I think there's something, you mentioned one called the Pebble.
Yeah, the Pebble was kind of a community inspired device. It connects up with your Android operating system and has small applications that run on it.
Yeah.
So all of these items have some characteristics in common, Mark. Well, one, of course, they're cool because they're gadgets.
Well, yeah, they're gadgets. It's very good. Who doesn't want to be James Bond with like the super multifunction watch that's a laser and get your email?
Excuse me, but that's like Dick Tracy, with the little video.
Oh, yeah. Or Get Smart with the shoe phone, right? The phone.
I tried that once, but a bunch of people stared in a train in DC.
Yeah, the guy's standing there talking into your shoe, kind of crazy. So these aside from being cool, similar to like we have a whole episode that we did on mobile performance for like mobile phones and tablets. These gadgets are even smaller, but they still run apps just like other apps, like on an Android operating system, right?
True, and there's a lot to be learned from mobile when we start looking at these gadget devices. And I think what's inspired this conversation, Mark, is since Apple made its announcements earlier this week, I have had a ton of questions of how do I test a watch? And does this tool support watch testing? And does that tool support watch testing? And this vendor hasn't issued a press release so they don't support watch testing. And I'm like, come on, guys, let's draw back a little bit and let's look at architecture and take a look at what's going on with the gadgets, how they're put together, and what we can use from our existing foundations to test them.
Yeah, because this is, let's be honest, the basic architecture of a gadget is going to it's a mini computer. So you've got to have some kind of processor built into the front end, right? So usually a gadget has a user interface of some sort, like a watch, or the Google Glasses are a good example, right? There's a user interface right in front of your eyeball. And then the actual way you interact with the app is through gestures and other kinds of things, which is pretty cool, touching the actual side of the glasses. So there's some kind of input. And like anything in performance, if the first thing we think about is response time, the user interface is really the key part of that first experience of a gadget. When you boot it up, how long does it take to log in? How long does it take to set up? How long does it take to do something? And usually, much like any app, the gadget itself is the client. And so the second part to think about is that traditional request response kind of framework. So if you just think about it those two ways, the gadget app user interface, as well as the back end round trip to the rest of the app, it's very similar to any kind of mobile app or any, even the client server model still applies sort of at a very high level.
And what we're seeing with these gadget applications is maybe a little bit different than the traditional phone app.
Yeah.
Is the gadget apps tend to operate in a somewhat disconnected mode. So
more disconnected than connected generally.
Yeah. So think about a Fitbit. Think about a calendar app on a phone. It's going to synchronize with your calendar occasionally, but hopefully it's not going to be constantly syncing 100% of the time. It'll sync with your phone periodically for updates, but this actual connection all the way back to the server, either directly or proxied, should be sporadic in nature.
Yeah.
Kind of respectful for the bandwidth. Think of the Apple campus. Everybody gets an iPhone on their desk the day after it ships, and everybody puts it on all at once. What happens to the Wi-Fi connection in the office?
Yeah.
Exactly.
It just goes nuts.
It could happen.
Yeah. So I think if we start at the very high level, if somebody says, hey, let's say you're a tester and the product owner or business person comes and says, we're going to launch our app on Google Glasses. And like good performance testers are always kind of talking about what's the real world situation, right? So again, if we're looking at will this app as a use case even make sense for this gadget? So let's say you had a proprietary gadget in a 24-hour Planet Fitness gym, YMCA kind of thing. And the only place that those gadgets were going to be used were right there in the gym. Maybe has power over RF, Wi-Fi, plus it has sort of a dedicated, always connected, always on kind of Wi-Fi connectivity. That app, if you started designing it to be mostly offline and invested in all this other, one size fits all kind of gadget asynchronous capability, boy, if the gadget is going to be mostly connected all the time, then use the connection. There's no sense in actually building the gadget the otherwise. Vice versa, if you're going to build a gadget that is connected on Bluetooth while you're going on a run for 15 miles, mostly disconnected, wow, you're going to chew up a lot of battery juice synchronizing when, I'm just running. I'm not looking at the gadget. I just want to strap it on or put it in my shoe and go for a run. And so I can be mostly disconnected, but sync up my data when I get home. So building, thinking about the context for the performance of the app, where it's going to be used and how it's going to be used, connected or disconnected. You're right. It's very different than the way we think of a phone. Phones now we think are almost always connected. It really is a mini portable computer. They're hardly ever disconnected, right?
Yeah. So Mark, I have a Nike Fuel Band.
Yeah.
Probably not surprised, but
Yeah,
I've got one because I'm a gadget guy. I got to have a gadget.
Yeah.
And I can have that thing on. I can be doing stuff all day long. And then I can choose when I sync up either through an app on my phone or plug it into my desktop computer and sync up that way.
Yeah.
it's not a situation where I'm going to have this constant behavior going back and forth. And so think about that from, as you said, a use case perspective. You have this synchronization activity that takes place. It may be of different sizes, depending upon when somebody syncs, whether it's daily, weekly, monthly, depending upon the application and such, how much data is flowing. Or if the developers have snuck something in there that maybe forces a sync on occasion.
Yeah, you want to watch out for those people who aren't really thinking about being totally disconnected mobile. Keep in mind, these gadgets, the majority of them have very small batteries, so they use typically very low-powered processors. So they're not known for being super responsive, interactive, but they build incredibly lightweight OS and app infrastructures that run, on very, very low-powered processors. So that means you need to watch out for any runaway code, something that's stuck in a loop, something that chews up the CPU. And you might have to get into the proprietary kernels. Like if you go into Android and you're looking at debugging the tools in there, Xcode for an iPhone app like you used to, some of these other operating systems that are running on the gadgets are totally proprietary. So it's really hard to assess other than just battery juice. Like if the battery juice is going down really fast, that's a good indicator that you're chewing up the battery, chewing up the processor. Another way to look at it is screen brightness. So if they have any kind of brightness, like the fuel band is very efficient LED kind of lighting, I think, to minimize very low voltage display. The Google Watch and even some of we've seen these other Windows has the other watch one. They're very bright display. And any pixels, any kind of drawing or display lighting, that chews up battery as well. So keep in mind power is a commodity. It's a very small, very limited commodity on a gadget
not only
device.
that, Mark, but when you start biasing end user performance, if you're low on battery and a request is made for the display, something has to give. And that might be your Bluetooth connection to your phone cuts down to a lower speed. Your Wi-Fi connection cuts down to a lower speed. Yeah. Your cell connection drops and prefers Wi-Fi or Bluetooth. So all of these things can have an impact on performance, particularly if you have some sort of dynamic data exchange going on at that period.
Yeah. So if we think about the app itself, the CPU, the disk, the memory, network, and the power on the device, that changes depending on whether you have full power, middle of the road, medium power, or almost out of power. The workloads on the back end might be different. Like if the battery is going down, you might see some shutdown, some writing stuff into flash memory, or actually submitting stuff across the wire. Keep in mind the back end of these apps, even if they're going over Bluetooth to the phone device, ultimately almost all these gadgets are connected to the internet. That's what makes them so cool. So James, I mean, a lot of the infrastructure in the back end I'm seeing is just web service type infrastructures on the back end. That's not so different.
Right. So if we take a look at the architecture, we peel away the shell of what's going on the GUI, even if the connection is via Bluetooth proxied through a phone or across HTTP or cellular, these tend to be web services applications because it's not very efficient to bring an entire website to the disconnected device. Mm-hmm. So we have a rendering, which is local for the user interface. Then we have a web services interface for the actual synchronization of data going back and forth. And that synchronization could be over Bluetooth to the local phone where I'm pulling the calendar from the phone, in which case that's not really a testable use case because we're not going back to a server per se for a traditional performance test. But if we're exchanging data with a remote service of some nature, say we are synchronizing our calendars with our colleagues as a part of Google Calendar or Microsoft Exchange or other services, then absolutely, then we're going to want to track those data flows, pull them, and represent them somehow.
Yeah. So the success of an application from a gadget application, a gadget app, from a performance perspective, is that you can deliver the minimal amount of data to satisfy the end user in the use of their gadget without having to chew up CPU, without having to go across the wire. So as you're testing, And we'll get into next. We'll talk a bit about, how you can actually design a good performance test for these kinds of apps, James. But also think about, using the tools you have to work in these gadgets, which is a real dilemma. I had a recent interview with Raj Subramanian on STP Radio talking about his research for just mobile testing and finding vendors that could support different tools. And he's like, it was a total crapshoot. It was like, one vendor supports one thing, another vendor supports another. I'm thinking about needing to instrument the application in order to capture these HTTP requests, which is really a tall order for most devs. So I think, James...
No, Mark. I think leveraging our expertise and how HTTP is architected, we can stick a proxy out there and capture these things, and almost all the tools support it. But gosh, a lot of developers don't know to ask that question.
Yeah.
Do you support a proxy recording model so they don't have to build the instrumentation right into the tool?
Right. And that's sort of the difference. If you're talking to someone, you need to know, again, both of those parts. Do you want to test the performance of the application on the gadget itself, or do you want to test the back-end calls, the network and the server calls, for concurrent load of those gadget workloads? And those are two different things that actually fit together really well, and HTTP proxy recording works really well. The thing that drives me nuts, James, is you'll find people that come to the table and say, well, I recorded the traffic, and then off they go and they just test the network and the server, and they completely forget about things like the power state. They forget about disconnected behaviors. They do a pristine recording once, but they don't redo that recording under low Wi-Fi. They don't redirect that traffic and see that it's actually different if you're connected through a phone versus connected direct through Wi-Fi. So apps behave differently now, depending on what gadget connectivity you have.
Yeah, if we look at that resource map of the CPU, disk, memory, and network, the one that is most heavily biased on the gadget side is network. And
just like mobile.
Just like mobile. And just like mobile, you need to be looking at how you're going to have an impairment model for your users, which represent how they're connecting. Because these mobile devices, these gadgets, they all have a longer latch time. That is a hold on the resource on the server when they connect. And as a result, a smaller number of mobile and gadget devices by extension can take down a server than desktop.
Yeah. So, James, let's come back after we chat, after we have a word from our sponsor. And then let's talk a bit about how folks can change up their design of a load test for these gadgets. Are you ready?
Yeah.
Hosting for PerfBytes.com has been provided by NUCO, New Centers of Excellence in Performance Engineering, PowerTest Professional Services, The Script Farm, LoadRunner by the Hour, Videratech, Cloud Architect, and No Load Test. For more information, go to www.newcoe.com or call 703-856-8187.
Beautiful. Special thanks to the NUCO guys. All right, so PerfBytes listeners, the way you are traditionally planning a load test, which is to sit down and design, what are your top 5 transactions, and what are the response times that you want for those transactions, and how many users of each type, and how often are they going to do what they do? All of that still applies to testing gadgets. The client is the only thing that's different. But for the back end systems, the behavior is going to be different. That load is not going to be as constant because, again, a lot of these gadgets are disconnected. So what you'll see is for a single virtual user that it'll sort of wake up and maybe synchronize a bunch of stuff and then do a bunch of very small things. And James, what you brought up was, sort of look for sort of small workloads or payloads for the normal traffic. But then every now and then you're going to have this burst of, a gadget, I got a connection to the internet. Boom! I'm going to resync and send a bunch of data, which is very different than kind of the, even pacing that you might see from a web type traffic, right?
Right. And you have to worry about these gadgets that have different synchronization models. If you have a user-based synchronization model, then for, say, Fitbit as an example, you might be synchronizing at certain times of day related to people working out. So you might have these bubbles in the morning where people are syncing, and a bubble in the afternoon, late afternoon, as people are syncing their behavior. But if you have a calendar application, which maybe is a push app of some nature, that is, it gets pushed from the application to the phone, and then your Moto 360 watch syncs with the phone, then that's a different animal in that case, where the synchronization and actually synchronization could be bidirectional in that case. I create a new calendar event on my phone, and it goes to the internet, and it goes to the watch, and there's no additional data flow there.
Right. The other thing I'm thinking is that, don't forget part one that we talked about, the first part, which is the user interface. When do I stop the stopwatch or the gadget watch? No pun intended. You know what I mean? So if you've never observed how real people are going to use the gadget in the real world, you don't really have that full understanding of when even the back end traffic comes all the way back to the device. You may be just capturing the traffic that ends up on the phone, but there's actually even a few more, maybe even a couple of seconds before it appears on the gadget over Bluetooth. So, or the gadget can actually make use of this information if you're proxied through or your traffic is going from Bluetooth and then, basically tunneled through that.
And Mark, this is where it's critical to get an understanding of how your users are going to use your device, your gadget, with some sort of in the field beta or alpha. Give it to your employees, let them go out. Don't tell them how to use it. Don't tell them how to sync.
Yeah.
Just get them, have some natural behavior going. And this is where an examination of that 100% of user load in your web logs is going to be extremely valuable, because you're going to be able to see where the requests are, which are distinct to your gadget, where they're coming in, and how much data is going back and forth.
Right. I think people should actually go watch, especially because the gadget is so tactile, different than sitting at a static location like a desktop or a laptop. Go actually watch, go to a tech conference where there's people walking around wearing Google glasses and see how they respond to information. And I was talking to this guy once who's got the glasses on, and he's talking to me, and you could see him all of a sudden look to the corner, and he's completely distracted and stopped talking to me. And I'm like, okay, did you just, what are you watching? It was very awkward. It's very antisocial, I think.
Mark, I think we know how they react. That's why they have the nickname they have.
Oh, that's okay. Okay, good.
that would be Glass Angels. Yeah.
Yes, Glass Angels. Yeah, they're very geeky. So go watch somebody use Nike Fuel Band's a good example. Let's say we're going to go to a gym, the YMCA, go to the Planet Fitness, and actually watch people who, do they ever interact with it? Do they put the Fuel Band on and just forget about it? And is that really the goal? I mean, is that how the gadget is supposed to work? Now we look at an Apple Watch. If you build an app that goes on an Apple Watch, is it, do your users bring up the application and interact with it, or do they punch a couple buttons and then go about their business, set it, and forget it?
Here's a really good question. Does the Apple Watch replace the iPod or the iPhone in that case when they're going to work out or do other things?
Sure.
So now we're synchronizing our Bluetooth headphones to our watch versus synchronizing to the iPhone or the iPod. We have a smaller set of data. Yeah, I don't even know if the iPhone can do this, so I'm just hypothesizing here. Mm-hmm. We've downloaded 15 songs to the iWatch. We're going to sync over Bluetooth, and now we don't have to carry the iPod Nano, the iPod, the iPad, the iPhone, or anything else with us.
Something. Yeah, exactly.
Also, the iDevice universe. Yeah,
the iDevice universe. But also think about the connected or disconnected worker who's, I remember like the UPS guy coming around, or the FedEx guy, and their gadgets, they had full tablets for a while, and then it got smaller and smaller and smaller.
Yep.
And the productivity of an employee who just needs information like notification through the watch. Hey, here's your next appointment, whatever. You're not getting reminders from your phone anymore. You get a reminder from your watch, which is not so different than Timex from 40 years ago. You used to set a beeper and all of a sudden,
there's one class of gadgets that we forgot to mention. So I guess I should bring it up now, which are these disconnected cellular credit card terminals. It's the same type of situation. You have web services call. Sometimes they're synchronized through the phone. Once again, it's a gadget device.
So let's come back to that in a second when we talk about talking about the security stuff. If you're designing a performance test for the gadget, again, the backend systems will be very similar to a web services test, kind of business as usual, but the patterns of the workloads will be different. Think about also what is the operating system and the devices. Let's say you're building an Android app. Well, there's a whole bunch of those Google Wear devices. Which gadgets are you compatible with? Which ones are you targeting? Does your product owner know all the compatibility that your app needs to have? And then we talked about observing the workload in the real world. And then I think also you get back to the network again. If you're designing a test for any kind of mobile app, especially on a gadget, and you're doing load testing or you're emulating that traffic without the network impairment, the HP network virtualization, the old Shunra stuff, or any other kind of network impairment that you can, packet loss, latencies, different bandwidth constraints, different connectivity profiles, switching from Wi-Fi to a Bluetooth to a cellular, 4G, 3G, something like that. So if you don't have that network impairment in your test, you should.
Yeah, I'm a big proponent of testing in the worst possible impairment.
Yeah, because if the app can survive that, it's probably going to do fine in the full mode.
Exactly.
I think perpetually we're always recommending that as the performance tester to build good relation with your brothers and sisters across take your architects and developers out for pizza and a beer.
Yes.
See if they really understand how the app is going to perform in the real world. Have they thought about how, what if the gadget really takes off this Christmas? 2 days, maybe Christmas Eve or Christmas morning, you're going to have a flood of setup traffic. So what's the overhead of the initial setup? Maybe even people have seen the gadget is fine, but the user setup phase on a regular website web call brings the site down. So we don't want to talk about you on the News of the Damned on December 26th this year as you launch your gadget. There are different phases of use with these gadgets, and sometimes the setup cost can be really, really high. So maybe having one scenario, which is like day one scenario, 4,000 users all setting up and using the gadget for the first time, is very different than a day 10 or day 30 scenario where everyone's already kind of got their profile set up and everything's in the groove, and the payloads maybe are much smaller for synchronizing. I can think of several manufacturers for certain gadgets in the past that just never thought about the day one scenario where nobody had to fully flash all of the latest, greatest microcode, the bytecode on the device itself, and all of that brought the system down in day one. So make sure you know your game day scenario there.
Absolutely. Take a clue from Ethernet, the collision multi-detect and retry. So if you try to get a connection and you can't, back off and try at random intervals. Don't just continue to try to pound the server. Be respectful from an application on the network basis. And, beer and pizza always works. Alcohol loosens the lips. They'll tell you all their concerns. Food, way to a developer's hardest through their stomach. Absolutely. Feed them, beer them. You get the right answers.
That'd be good. So as you're designing any good performance tests, gadgets or otherwise, you're going to want to think about also monitoring and how do I optimize this app? And James, you kind of just talked about one there, which is if we have some sort of reconnect scenario, and you don't want to have this static sort of rollback kind of reconnect storm. You see this in Gmail, actually. If the asynchronous client within Gmail, if you're using it, it'll say, cannot connect, trying again in 7 seconds.
Yeah.
And then if that doesn't connect, trying again in 33 seconds. So it actually takes, this is also really critical.
And you know what? That algorithm is done. It's baked. It's well known. It's well understood. There's a big, long, 14-digit character algorithm label for it. It's collision multi-detect, blah, 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 blah.
Exactly.
But it's basically the basis of Ethernet.
Yeah.
If you roll that into your app, you don't get a connection in 10 seconds, cut it. And then, back off, retry until you get a connection to avoid that storm.
But think about it differently for the gadget is my point. If you're sitting on a desktop with a web or a server with a network connection, you have almost unlimited power and unlimited capability. With a gadget, if it just sits there and retry, you're going to, in some kind of a loop, you'll probably burn out the battery. So when you finally do get a connection, you want to have plenty of battery juice available in order to complete the transaction. Also, you have limited disk space. So let's say in a strange way, you're kind of keeping track and maybe there's a memory leak or a log of some sort that's actually kind of adding. Every time you resync, you might fill up the space because you have limited space. So gadgets really can benefit from this multi-detect resync kind of logic that you describe. And it's not just Ethernet at a physical layer. I think logically as an app layer, we leave a gadget. Hey, I took my Google glasses off for dinner and I just set them, or I went on the train and suddenly I'm out in the country where there's no connectivity.
Yep.
It actually could be 30 minutes or an hour before I can actually resync. So please don't chew up my battery and my CPU just trying to do that again. When it comes to monitoring, and this is my big slam against us as an industry, where a lot of the tools for these gadget operating systems, you have to have some sort of developer interface or an admin interface, maybe a raw system interface to the device in order to measure things like CPU, disk memory, and network. Those are the things that we want to monitor. And like I mentioned before, sometimes the only way you can sort of infer that there's a chewing up of the CPU is because the battery juice is going down so fast, the percentage battery usage goes really high. So to monitor the device itself may take some extraordinary effort. And there are some toolkits out there, obviously, with mostly software developers know these toolkits. Like, for instance, doing an Xcode interface to a connected iPhone, you can start monitoring things like memory usage and CPU and that through the APIs that are connected on the device. A lot of people check these things through emulators. If there's an emulator, it's valid. It's not the same as a physical device, but it'll give you at least something's better than nothing, right?
Yeah, and it'll tell you if you've got a code leak. That's for certain on the emulator.
At least, and again, it's better than not being able to see anything at all. If it's certainly not going to work well in an emulator, it's probably not going to work well on the device either. Because I think we're going to a more constrained model once we get physically running. Power usage is still, I think, the biggest thing. Outside of network, James, I think with these gadgets, power is probably a big, big concern. Just because even though lithium batteries or other types of battery cells, energy cells have gotten more efficient, it's still limited space. Like I have a battery inside my glasses frame. There's just limited physical space to have a battery. And the one thing we hate, unless we can fully get the Tesla model for charging over Wi-Fi, which, we do have wireless charging, it's just not that efficient. Hopefully that'll get better. But monitoring, use the app for 5 minutes and measure the battery. Use it for another 5 minutes, measure the battery. And this is where Gina N. Harrison would do a marvelous job of telling us exactly how you would monitor these things physically as well.
And she would let us know what we're missing in the discussion as well.
I know. She's good at that. A couple of the other things you talked about, data flows again, James. So if you're going to monitor the network usage, this is maybe where we might want to encourage people to have your simulated load through virtual users through your load testing tool, Load Runner or whatever tool you're using, but then also monitor a real connected user through, let's say you can monitor the Wi-Fi interface, or maybe you come through like some Connectify and some of these things you can put on your laptop so the device connects to your laptop Wi-Fi, and then you monitor the bytes going through, or you can even proxy that through Charles Proxy or Fiddler or something. You could see that traffic actually going through the laptop. And what kinds of things would you look for in a data flow, James, that would send you off?
Well, one thing is I want to make sure that they're as small as possible. Absolutely. Everything has got to be compressed. You're on Bluetooth or you're on other networks that are very low bandwidth. Compress everything.
Mm-hmm.
Since also you're kind of in the wild, and there are people out there that have, Bluetooth sniffer like devices, always encrypt the conversation if at least it's going from the device to your phone or the device to the next upstream link. Make sure it's encrypted. I also want to see that it's web services. I don't want to see a GET or a POST. I want to see a really small request, well-defined. And actually that has benefits to us from a performance test and performance engineering perspective, because those web services requests are usually well-defined in advance of when the device is actually available for testing. We have the capability of testing early and often and engaging in this shift left process where, you can have developers doing some sort of really pound the snot out of it testing with, let's say, a JMeter or a grinder or something.
Mm-hmm.
And then as you move through the life cycle, get more business level testing or user level testing a little bit later, which may or may not use the same tool depending upon the needs of the team and reporting and stuff.
Exactly. So you may know what the infrastructure is before the app is even complete. You can make sure that that's fully scalable, responsive, and ready to go before you actually hook up real devices. But don't forget that if your simulation is off by a little bit, you still want to observe what that real device looks like. Less suddenly, and day one, boom, there's a huge sync to download a bunch of stuff to the app. Or if you're disconnected for 24 hours and the first sync after that, what does that mean? And then the interactive stuff, depending on what kinds of sites or what kinds of calls are going to be made. Look at Google Glasses, right? They're going to do a Google search. Well, they have a very, very homogeneous Google search page that delivers payload back to the glasses. It's not, obviously if you do a Google search, it's pretty much a normalized kind of behavior versus just wild surfing of any page on the internet. So thinking about what kinds of calls are going to be made by a user with the gadget. Are they really going to be surfing any old page on the internet from their iWatch? Or are they really looking for sort of more conformist, normalized kinds of interactions? So yeah, web services is probably exactly the type of infrastructure that's going to be on there. So that's kind of Gadget Performance. We didn't go too deep into it because it's also very similar to mobile. And I think our previous episode on mobile performance went a little bit deeper. But if there were a couple of 2-3 pieces of advice, what are the things off the top of your head, James, that you want people to take away?
I would say strip away the architecture. Odds are, greater than 90+% of the time, it's going to be based upon HTTP. So you should have a great foundation of work that you can draw from for how you're going to build these tests from a technology standpoint. Don't be scared of it. And talk to the business owners when they ask, can you test watch? Ask them specifically about the architecture, and odds are you'll get the answer. It's based upon web services, and then it's an easy answer.
Yeah. And a lot of people try to just copy and paste their iPhone app onto a watch, and it may not actually be the same experience at all.
Yeah. That's not going to work in that case.
Yeah, in that case. So my advice is also just to be aware that you're going to have challenges if you try to get onto the device itself. And for that, we maybe invite Jean Ann to come talk about it, or come join us at STPCon. We'll have a scotch and talk about how you crawl into some of these devices through the developer interface or a system terminal, which would be very cool. Well, hey there, PerfBytes listeners. Once again, you've come to the end of another thoroughly minimized and gadgety episode of PerfBytes. And as always, we'd like to thank you for sincerely taking the time to listen to the show today.
Mom, thank you for tuning in. You're back from the beach. I know you've got a busy weekend unpacking. Thank you very much for tuning in.
Yes, and I will always give my extended thanks to the sexy Irish voice of PerfBytes, who was washing clothes earlier tonight. I had to turn off the laundry. And of course, special thanks to our sponsors, the Smart Bear folks with Load UI, Soap UI, and all the exciting things that Mr. Barber is doing up in Boston. Quite a commute he has going back between Florida and Boston,
Yeah, that is a heck of a commute. You know what? He could take advantage of what our episode is powered by today, Mark. which are reruns of the TV series Firefly.
And of course, please remember that the content of this PerfBytes is copyrighted and protected, just like the earring-based Caller notification that is currently in my left earlobe. Wait, excuse me, hang on. I'm getting a meeting request. It's in my ear. No, it's.
I was wondering what that buzzing sound was. Yeah.
No, you can look at the earring, but you cannot touch because otherwise you'll accept another meeting invite. I can't do that.
For more information about PerfBytes, please visit the show's website at www.perfbytes.com or follow us on the Twitter and the Facebook. And of course, you can always tune in and subscribe through iTunes, TuneIn Radio, Stitcher, iHeartRadio, or probably, thousands of other locations on the internet that take our shows and push them out to the universe at large. Just search for PerfBytes, click subscribe, make us part of your favorite daily shows.
Sure. Like Mike Lyles, just listen to us on the commute every day. The PerfBytes show and staff are supporters of the Practical Performance Analyst, the Performance Engineering Book of Knowledge, the Computer Measurement Group, the Workshop on Performance and Reliability, and of course the Software Test Professionals community of software testers. And we hope to see you at the next STPCon. It should be a really good time. And of course, I'll also be at the Workshop on Performance and Reliability. If you've never been to a Whopper, you can check out more at the workshop performance-workshop.org, which is very exciting. Thanks for joining us on PerfBytes. We'll see you on the next episode.
Have a great week, everyone.